Hi grade 12s and welcome to my YouTube channel. In this video we will be solving the mathematics paper 1 June 2024. I have the paper opened and it's the KZN KwaZulu-Natal province paper. So let us go straight into question 1 and solve this entire paper. So solving question 1. Right, we want to solve this problem. As we see that this is already factored out, so since it's factored out, we can just write down the answer. X is equal to 0, or x is equal to, remember to take that over, so minus 7 and then divided by 2, so minus 7 over 2, or x is equal to, obviously taking the x over, and so x is equal to 8. So because 8 minus 8 will give you 0, so or x is equal to 8. So these are the three answers. Let's solve question 1.2. Right, as we see here, they didn't say 2 decimal places and stuff, so I'm sure this here can factorize. So we're going to factorize it with x, and x equals 0. Now factors of 12 are 12, and 12 times 1 will give me 12, and 12 plus 1, so plus 12 plus 1 will give me 13. So x is equal to negative 1, or x is equal to negative 12. You can also do this on the calculator. If you have the silver calculator, then you can go to mode, equation, and select the quadratic option, which is option number 3, ax squared plus bx plus c, and press these values. 1, press equals, 13 equals, 12 equals. What's nice about this is that it will give you the final answers, so you just need to work backwards. Take the minus 1 over and take the minus 12 over and put it into brackets. So leave a space here and then write down the answers. See, we got x equals minus 1, or x equals minus 12. So all I'm going to do is working backwards. I'm just going to take this over, so I will get x plus 12, and take that over, I'll get x plus 1. I hope you understand, guys. Taking question 1.3. Right, so we're going to attempt to solve this on the calculator and check. If it doesn't work out, then obviously we will use the quadratic formula. So let's use the calculator as we're doing. So option number 5, option number 3, 5 minus 7 and 8, press equals. Right, so what is this? 5 minus 7 and 8. 5 minus 7 and positive 8. So this here doesn't work out, so we're going to have no solution. Let's check. So what we're going to write is delta equals, we're going to work out x equals, use the quadratic formula, plus minus the square root of b squared minus 4ac, right? The square root of b squared minus 4ac divided by 2 times a. We know the value of a is 5, the value of b is minus 7, and the value of c is equal to 8. So let us substitute everything. X equals, minus b will be minus b will give me minus 7 plus minus the square root of b squared minus 4ac. What is b squared minus 4ac? Minus 7 all squared minus 4. A is 5 and c is 8, and divided by 2a. Right, and then we will divide it by 2a, 2 times 5. And if you try to simplify this, we can say x equals 7 plus minus the square root of, so we got a problem here because there's no real solution, because that's 49 minus 4 times 5, that's 20 times 8, 160. 49 minus 160. So go to mode 1, 49, because minus 7 squared, right? That's 49 minus 20 times 8, right? So what we're getting is minus 111 divided by 10. Right, now what we can say is that no real solution, because you can say since delta, which is b squared minus 4ac, is less than 0, which is how do we know that it is less than 0? Because it is equal to negative 111, which is clearly less than 0. You can say no real solution for x. So no real solution for x. So what type of solutions exist? The types of solution exist is basically complex solution. 5, 3. Again, you're going to enter 5, minus 7, and 8. If you enter that, we're getting 7 over 10. Clearly 7 over 10 plus minus. Now, what's important in complex solution is we call the square root of negative 1 is equal to I. In other words, I squared is equal to negative 1. Right, so just to check what type of solution we get a complex solution. So no real solution for x, so which means there's a complex solution, which is 7 over 10 plus minus square root of 111 over 10i. So you can write this answer down, which is basically two answers. You can write one positive answer down, or and write the negative answer down, which is 7 over 10 minus the square root of 111 over 10i. You know what is I? I is the square root of minus 1. Anyways, we should write no real solution for x. You should be fine there. Continuing with our problem 1.1.4, we have a third equation and it's 5 marks. So not bad, not bad. Let's see. It's 5 marks, right? So what we do with the third is we take everything over to the other side. We take the numbers over third on one side. So we got x minus 2 is equal to x minus 2. Now what we know is the square root of anything is always positive, so we kind of have a restriction that x minus 2 has to be greater than or equal to 0. In other words, when we choosing a solution for x, it must be greater than or equal to 2. Taking that over, that's my restriction. So I can only choose answers which is greater than or equal to 2, otherwise no other values. We can't choose a value like minus. See, x greater than or equal to 2 means you start your answer here and you can only take answers on that side. So let's continue here. Your answer can be 2 and any real number in between. So how do we solve this problem? We square both sides, right? Now squaring both sides leaves us on this side with x minus 2. When we square root, it falls out, right? It disappears. X minus 2 all squared. That's squaring a binomial, so you square the first term, which is x squared. You square the last term, which is plus 4, and the middle term is the product of x, the product of the two terms times 2, so minus 4x, right? Because x times minus 2 is minus 2x, times 2 is minus 4x. Now taking everything over, so you're gonna get x squared, bring the x over, you get minus 5x, plus 4 plus 2 is plus 6, and we can clearly factor this out. So let me show you the calculator method, because obviously you are allowed to use a calculator, right? And actually it makes life really simple, right? So mode 5 3, let's enter 1 minus 5, 1 minus 5 and 6. See, we got an answer of 3, and the second answer is 2. We got 3 and 2, so if you bring that over, you'll get x minus 3. If you bring that over, you'll get x minus 2. Perfect. And what answers can we choose? Can we choose both the answers? Yes. Let's check if both the answers actually work. So let's put 3 inside here. So we got 3 minus 2, which is 1. Root 1 works. Root 1 plus 2 is 3. 3 is equal to 3. That works. 2. If I substitute 2 inside here, yes, both the answers work, so we reject none. Both the answers works. And remember, the answer that you choose must be greater than or equal to 2. So both these answers work here. So moving on to the next question. Right, so 1.1.5, we have a nice quadratic inequality question. Now how do we know it's a quadratic inequality? Because if we open this up and make it into standard form, you'll get a trinomial. So we got x squared minus x, bring the 20 over, minus 20 less than 0. Now again, you can use your calculator and put opposite sign here. We're going to write x and x. Why are we writing x and x? Because it's x squared. X times x is x squared. You can clearly see 4 and 5 is working out, so I don't want to use it, right? So minus 5 and plus 4. So plus 4 minus 5 gives me minus 1, and 4 times minus 5 gives me minus 20. Now to solve this inequality, we're going to draw a number line and write minus 4, and we're going to write 5, because those are the critical values. Now to figure out the sign, substitute any value after 5, right? If I substitute any value after 5, like 10 plus 4 is positive, 10 minus 5 is positive, positive times positive gives me positive. So now you can alternate the signs because it's linear factors, right? And positive. And what answer do we want? We want an answer which is less than 0. Less than 0 means it's negative answer. So we're going to take an answer between 4 and 5. Right, that's my answer. So minus 4 less than x. X is greater than minus 4 but less than 5. Or you can write your answer in interval notation. X is an element from minus 4. Make sure to use round brackets. Minus 4 to 5, and use round brackets at the end as well. Moving on to the next question. Right, so that's my answer. We have a nice exponential equation here, right, for 5 marks. Let's see if we can solve this. Right, so in this exponential equation, what do we have? We have 2 to the power, whoa, so we got 2 to the power 2x, right, negative 2x, and we got a negative x here. Okay, so what we're going to do is first split this up. So you got 2 times 2 to the power, see how I'm splitting it up, negative x and squared. Why we're writing it like this is because we want to make a trinomial and solve. So I wrote 2 to the power negative x squared. Remember, this is 2 to the power 1 because I'm trying to decompose. Remember, 2 to the power 1 minus 2x. I'm decomposing this. This is 2 to the power 1 times 2 to the power minus 2x. Now the minus 2x, you can switch these around. 2 to the power 1, 2 to the power negative x, and square that. You can see negative x times 2 is minus 2x. So it's perfect to write like this. Plus 7 times 2 to the power negative x minus 4 is equal to 0. So what we're going to say is let k be equal to 2 to the power negative x. So see what you have, 2k squared plus 7k minus 4 is equal to 0. Now I will use a calculator, right? Since you're allowed to use a calculator, just use it, right? So k is equal to, or k is equal to, right? So let's put it here. Let's go back. So value of a is 2, value is 7, b value, and c value is minus 4. So what we have, half, k equals half, or k equals minus 4. Perfect. Now how do you put half? See this 2 becomes a coefficient of k. So you got 2k and bring the 1 over, minus 1. There's nothing to do here, just bring it over. So k plus 4, because you get marks for this, right, for putting that step, so you have to put that step. Now what was k? K was 2 to the power negative x. And what is half? Half is 2 to the power negative 1. What's k? 2 to the power negative x, right, is equal to negative 4. But now you're gonna write no real solution here, no real solution here, no real solution, since 2 to the power negative x is always positive. How we know that? Because of the exponential function. Can you see? It can't be negative 4. It's above 0. So this is 2 to the power negative x graph. Anyways, let's solve this. Since it's an exponential equation, we drop the base and equate. So what we have is negative x equals negative 1. Therefore, x equals 1 only. Multiplying both sides by negative 1. Right, so what's my answer? X equals 1. Perfect. Let us continue to solve the next problem. Right, quite simple so far. 1.2. Right, this question should be on nature of roots, which was done in grade 11 anyways, because we can see the form of the quadratic function, the answer in the quadratic formula form. Right, so the roots of the quadratic equation, roots means the x values, right? So you got 2 x values here, Right, now if m is an integer, determine the largest value of m. Determine the largest value of m for which these roots will be rational. Right, so how are we going to solve this? Largest value of m. So we need some restrictions on m. Okay, so we know 22 minus 3m, everything inside the set must be positive, greater than or equal to 0. So we can say negative 3m is greater than or equal to negative 22. So m is less than or equal to, because we're dividing both sides by negative 3, so you're going to get 22 over 3. So m is less than or equal to, what's 22 over 3? That's 7 and 1/3, so 7,333. So clearly we can't have, so that is the largest value of m, which is 7. Is it 7 or 8? Let's check. If I put 8 inside here, it's going to become negative, right? Because 22 minus 3 times 8 is minus 24 minus 2. You'll get the result as minus 2. But if you put 7 inside, you're going to get square root of 1, because 3 times 7 is 21. Alright, so if m is an integer, determine the largest value of m for which these roots will be rational. Largest value of m is equal to 3, m is equal to 7, largest value. Largest value of m for which these roots will be rational. Is it rational now? Put 7 inside. 22 minus 7 will give me 22 minus 3 times 7 will give me 22 minus 21, which is 1. Square root of 1 is 1. So 1 is a perfect square, so then this will become rational. Right, so m is equal to 7, which is the largest value of m for which these roots will become rational. We want to solve for the largest value of m. We're not actually solving for the roots. That's it. Right, so quite simple, nice theoretical problem. Now, why did we say that that has to be positive? Because everything in the square root must be positive in order for this here to have real or rational roots. 1.3, quite tricky this one here is, because we have a third equation, right? We have a third simplification, actually not an equation, right? So we want to simplify this. Now what we know is that, remember, 9 to the power 2024. So let's use prime bases. 9 to the power 2024 can be the same as, remember, when we're square rooting, nth root of x to the power m is inside over outside. So you can say x to the power m over n. So I'm going to write this as 9 to the power 2024 divided by 2. Okay? Because that's square root. Now watch how nicely this here works out. And that's 9 to the power 2023 divided by 2. Subtract 9 to the power 2025 divided by 2. Because there's an imaginary 2 outside. Now, if we want to simplify this, remember 9 we can write as 3 squared. 3 squared to the power 2024 divided by 2, and you can clearly see the 2 and the 2 cancel out. Same story here. Replace all the 9 with 3 squared, and then you'll find that the 2's cancel out. 3 squared to the power 2023 divided by 2, subtract 3 squared to the power 2025 divided by 2. Now you can clearly see that all the 2's cancel out, right? And then what do we have here? We got 3 to the power 2024, right, divided by 3 to the power 2023, subtract 3 to the power 2025. What we can do is we can take out the HCF in the denominator. So 3 to the power 2024 remains on top. Take out HCF in the denominator, which is 3 to the power 2023. 3 to the power 2023 can go into both. So you got this here divided by this HCF is 1. And 3 to the power 2025 divided by 3 to the power 2023. You subtract the exponents when you divide. So you see 3 to the power x divided by 3 to the power y, it becomes 3 to the power x minus y. So in this case, x is 2025 and y is 2023. Right, so you got 2025 minus 2023. So you got 3 squared, okay? And 3 squared is 9. So we can write this answer as 3 squared for now. And now we can say we're dividing here as well. So since we are dividing 3 to the power 2024 divided by 3 to the power 2023, we just left with 2024 minus 2023. So we just left with 3 to the power 1 divided by 1 minus 9. So what are we left with? 3 over 1 minus 9 is negative 8. So you can put negative 3 over 8. That's my final answer. I hope you guys understand. Next question. We want to solve for x and y simultaneously. We can clearly see it's so easy, this question here, right? So let's see how simple this question is. Simultaneous equation. You don't have an option, just use method of substitution. So let's see, don't go and solve for x, solve for y first. So we're going to say y is equal to 2x minus 3. Take the 2x over, so 2x minus 3. Now wherever you see a y, replace it with 2x minus 3. You can see a y here and a y there. Right, so what we have is, let's simplify this. So we got 4x squared plus what's y? Y is 2x minus 3 minus 2xy. 2x, what's y? 2x minus 3 minus 7 is equal to 0. So now this here will work out to be a quadratic. So let's solve. We got 4x squared plus, remember to square this, 4x squared. Square the minus 3, you get plus 9. Middle term is a product of these two. Minus 6, then times 2. Minus 12x. Minus 2 times minus 2 is minus 4x squared. Minus 2x times minus 3 is plus 6x. And we got minus 7 is equal to 0. I can see some terms cancelling out. 4x squared minus 4x squared cancels out. And we can see some like terms. 1, 2, and that one, and that one. So what we have is 4x squared. Minus 12x plus 6x is minus 6x. Plus 9 minus 7 is plus 2, which is equal to 0. Now simplifying this, we're getting 2x squared minus 3x plus 1 is equal to 0. I'm sure this here should work out. We don't need to use a quadratic formula. Right, so what we have is 2x and x, which is equal to 0. Let's just use a calculator. Obviously, factors of 1, you can only get 1 and 1. But because we want a plus here and a minus there, so that will become minus 2x minus x. So both should be minus. In other words, you should get x equals half or x is equal to 1. If x is half, put it inside here. So we get y is equal to, put half inside this function here. So 2 times half is 1. 1 minus 3 is minus 2. Or put 1 inside here. So 2 times 1 is 2 minus 3 is minus 1. Right, so those are the answers you should get. Let's check if this actually works out. 2x squared minus 3x plus 1. Let's see if those are the answers. So go to mode 5 3. A value was 2, B value was minus 3, and C value was 1. Right, so you can see you're getting an answer of 1, and we're getting we're getting the second answer as half. Right, and what's the y value? Put half inside here. 2 times half is 1, minus 3 is minus 2. Substitute 1 inside here. 2 minus 3 is minus 1. Perfect. So these are my answers. So that's my answer, and that's my answer in that pair. So solve for x and y. That's my answer. Right, done. Moving on to question 2. Question 2 is based on sequence and series. Right, so solving this, write down the next two terms of the quadratic sequence. So we're just going to write down the next two terms. So as we see here, because they're telling us this is a quadratic sequence, must have a second difference. So what are we adding from minus 5 to 12? We're basically adding 17 first, right? So remember, we added 17. Then from here to 12 to 27 we're adding 13. You can see there's a from 17 to 13 there's a reduction of 4. So then we're going to add 9. So term 4 is going to give me the next two terms. So 27 plus 9, which is equal to 36. And then after we add 9, which is 36, we're going to add the next number, which is reduction by 4, add 5. So, and term 5 will be 36 plus 5, which is 41. So the next two terms are 36 and 41. I hope you understand, guys. Now let us solve this general term of the quadratic sequence. So we're going to rewrite this. We just need the first three terms, alright? So minus 5, 12, 27. Whoa, not 13, sorry. That should have been we're adding 15 actually. That's wrong. Add 15. So first we added 17, then we're adding 15. 12 plus 15. There's a reduction of 2, so then we're adding 13. So that's incorrect. Right, so let's correct it quickly. 27, we're adding 13, then we need to add 11. So 27 plus 13 is 40 and 51. So we should get 40. Quickly, right, 40 plus 11, that's 51. Alright, so again, add 17, add 15, 12 plus 15 is 27, then add 13 because we're reducing it by 2. So 40 and 51, right? So that looks right. Now finding the general term of the expression. General term is Tn equals an squared plus bn plus c, and you know the formulas. 2a equals d2, so we're going to work that out. So we can see 12 minus 5 is 17, that's difference 1, and 27 minus 12, that's 15. Then difference 2 is 15 minus 17, which is minus 2. So what's the formulas? The three formulas. 2a is equal to d2. So a is equal to minus 2. Let's write down the three formulas, right? 1, 2 and 3. 2a equals d2, then 3a plus b equals d1, and a plus b plus c equals term 1. So there's your second difference, first value of the first difference, and term 1. Now 2a equals minus 2, so a is equal to negative 1. If a is negative 1, substitute here, so we get negative 3 plus b equals, what's the difference 1? 17. And 17 plus 3 is 20, so the value for b is 20. Now you can say a plus b, we can group that up. What's a plus b? That's 19 plus c is equal to term 1. What's term 1? Minus 5. So the value of c is minus 5 minus 19, which is minus 24. So what's my Tn formula? The general term is Tn is equal to negative n squared plus 20n minus 24. That's my general formula. Let's substitute 4 inside the general formula and see if we get 40 and 51, 4 and 5. So mode 1, so negative into 4 squared plus 20 times 4, right, minus 24. So what I'm getting, 40, right? Perfect. And then make it 5, we should get 51, right? So we know our fourth term and fifth term is correct. So yes, that should be correct. Well, I was going to check this my two answers either way using the formula, but lucky we figured it out here. Anyways, let's continue with the next question. type of question is this? Is this a joke? Uh, which terms of the quadratic sequence has a value of 51? Which term of the quadratic sequence has a value of 51? We can clearly see term 5 is 51. Anyways, let's write. So, well, if you have a question like this, you actually need to go and solve the thing. So, which term? It means Tn is equal to 51. Alright, so what's Tn? Tn is minus n squared plus 20n minus 24, and that needs to be equal to 51. Bring the 51 over, so you got negative n squared plus 20n minus 75 is equal to 0, because minus 24 minus 51. So you're going to write it in standard form. Don't ever work with negatives. Minus 20n plus 75 is equal to 0. So we're going to use n. We know the answer is 5, so n minus 5, and n should give me plus 15. Whoa, you might have more terms. That's the reason they said which term or terms. Right, so we know one of the answers is 15. So n minus 15 both works out. N minus 15 and n minus 5 is equal to 0. So you got when n is equal to 15 or when n is equal to 5. So remember, if you continue this pattern, you will find another term which is 15 term will be, because the way the quadratic sequence is structured. Alright, so let's see. We'll have a value of 51. Let's see, let's factor it. Let's see if we did the right thing. Minus n squared plus 20n. Oh yes, we can check it out. So we're going to say term 15 is equal to 51, or term 5 is also equal to 51. We check term 5, let's check term 15. So I'm going to put 15. Yes, so both the terms, term 15 or term, which terms of the quadratic sequence has a value of 51? So term 15 or term 5. So we wrote both. Right, good question that is. Let's look at the last one, 2.4. Calculate the value of Tn. So what are we doing here is basically we're summing up, calculate the value of n equals 3 to 10 of Tn. Tn is that terms, alright, and 11 to 17 of Tn. So we need to check what's happening. 3 to 10. So what we're doing here is we're adding up term 3 plus term 4 plus term 5, term 3, term 4, term 5 plus dot 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 plus term 10, and we are subtracting term 11 plus term 12 plus term 13 plus dot 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 plus term 17. Alright, so we are adding how many terms here? 10 minus 3 is 7 plus 1. We are adding 8 terms here, and we're subtracting 17 minus 11, that is 6 plus 1, 7. We're adding 8 terms, subtracting. Alright, so I think we need to find the pattern here. We know term 3 is, what was term 3? Term 3 is 27, 40 and 51. Let's write 27, 40, 51. 27 plus 40 plus 51 plus dot 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 plus, I'm doing the first part, right, plus what's term 10? Term 10, yeah, we didn't work out term 10, so let's put it inside the formula. So term 10, I just figured out another way, like you can use graphs to solve this. That is 76. Term 10 is 76. All right. term 10 is 76. Okay, was it plus 20 minus 24? Right, and then what's term 11? Term 11, we're gonna go check what's term 11. Term 11 is 75. Term 11 is 75. So we're going to add, subtract. What's term 12? $75, $72. $75, $72. Right, so how are we going to solve this problem? What if we just add up all these terms here? And right, obviously the calculator can give you the answer. We can just go and say sigma notation, shift sigma. Okay, I'm just going to work this out using a calculator. So I'm going to say minus alpha x squared plus 20 alpha x minus 24, right? And going from 3 to 10. So if I sum up all the values from 3 to 10 of that formula, I'm getting 468. And subtract the sum of all this from 11 to 17. Nice, we got the formula already fixed there. We're supposed to find a pattern by expanding 11 to 17. Well, if the calculator can solve it, why should I? Alright, so 392 minus 392. And 468 minus 392 mode 468 minus 392. I'm getting the answer is 76. So that's the answer I get. Okay, so that's what we got. Or see term 3. I think term 3, remember what term 3 was? 27. So that is 27. Term 4 was 27. What is term 4? 40, 51. Right, plus dot dot dot. And term 10 was, I think, what was term 10? Term 10 was mod 1 minus 10 squared plus 20 times 10 minus 24. It was 76, right? This is term 10. I think if we work out what is term 17, then we kind of like working out all the terms backwards. What's term 17? Let's see. Yeah, term 17. Let's see, term 17. Yes, term 17 is 27. So I'm writing this backwards. Then you're going to have plus 40, plus 51, plus dot dot dot, plus a term before this will cancel out. So all these terms cancel out, and then you can write out the, so all you are left with is 76. That's the reason why they gave us this problem. Alright, so now all this cancels out because you're subtracting. That's not till there, you're subtracting till the term before that, because there's 8 terms here and there's 7 terms here, so you can see all cancelling out, right? And then we just left with 76 minus 0, and our result is 76. Right, so we got the answer in 2 ways. I showed you calculator method and this method here. Also note that look at your quadratic formula, which is, look at your number pattern 20n minus 24. If you try to work out minus b over 2a, the maximum value that this graph can take on, x equals minus b over 2a, right? So you're getting minus, I'm working out xtp, looking at the graph of this function, minus b over 2a, we're getting minus 20 over 2 times negative 1, so we're getting 10. So the maximum value that this can take on is at 10, right? So at 10 this graph has a maximum. So if I try to draw this, remember this is the third method that I'm trying to solve this. So yeah, and how you're going to draw this quadratic function is like this. When the value is 1, what's the first term? It was negative 5, right? 1 gives me negative 5, so let's just put negative 5 here. Let's use the faint line spaces, so negative 5 will go here, right? So you can't draw it has to be a dotted curve at 1, and then at 2 we're getting a value which is 12, which is somewhere around there. Okay, kind of have an idea of what to do. So let's see, let's look for the x-intercept. Let's try to draw this graph. Mode 1, what's the x-intercepts here? Y-intercept is minus 24. So if I try to draw this graph, let's just draw the graph, right? And it's a sad face. So we know minus 24 is here. My x-intercepts will be, let's put it into the formula, 5, 3. It's going to be negative 1, 20, negative 24. So I'm getting, well, we're getting funny answers, right? So x-intercept, but anyways. So what we notice is that at 10 the graph reaches a maximum, right? And the maximum value is 76, right? And look at all the values before this. Like at 1 the value is negative 5, right? We don't care about those values. At 2 it is like 12, and then so on and so on and so on, because these points are symmetrical. Now remember, the graph not supposed to be like this, it's supposed to be like broken, not broken, it's supposed to be a dotted graph, because n is an element of yeah. So what happens is that the 11th and the 9th term will cancel out because of symmetry. So what happens, 9th and 11th terms cancel out, and then 12th and the 8th term cancels out. So the terms cancels out according to this, right? Right, so all the terms cancel out, the only thing that remains is at 10. So you can just say the answer for this, therefore the only term remaining is term 10, which is equal to 76. So sigma 3 n equals 3 to 10 of Tn minus sigma 11 to 17 of Tn is basically equal to a single term, which is term 10, and this is your explanation. You can also show, because we can see that the 9th term and the 11th term cancels out. So you can say term 9 minus term 11 is 0. We can say term 8 minus term 12 is also 0, and so on, right? So term 8 minus term 12 is 0. So let's put it here. You can also say term 7. So all these terms cancel out. So dot 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 till term 3 minus term, how many did I drop by? I dropped by 5, and then drop by term 17 is equal to 0. So the only term that remains is term 10. Nice question. So we've done this problem in 3 different ways. I used a calculator method, then I used the cancellation method where I put it as a backward sum, right? And the last one is using graphs. I hope you guys understand. Moving on to the next question. Question number 3. We can see this is an arithmetic sequence. So finding the general term of the arithmetic sequence a plus n minus 1d, right? They're telling us is arithmetic, so Tn equals a plus n minus 1d. You can check this in your formula sheet. A is minus 7 over 2 plus n minus 1 times d. What's the common difference here? Minus 3 minus 7 over 2. So difference is minus 3 minus 7 over 2. So you get half. So we're getting times half. Now we substitute this inside. So you're getting minus 7 over 2 plus half n, okay, minus half. So what we got? Half n minus 7 over 2 minus half, that's minus 4. Let's substitute the value of 1 inside. So we're getting half minus 4, which is 7 over 2. Substitute 2 inside, we're getting 1 minus 4, which is minus 3. So perfect, it works out. Moving on to the next question. (3.1.2). The sum of the first n terms of the sequence is 675. Find, calculate the value of n. So you know what the SN formula is. The sum of the first n terms of the sequence is 675. Calculate the value of n. So Sn is equal to n over 2 into 2a plus n minus 1 d. And they're telling us that this sum is equal to 675. So we need to solve for n. So we're going to say n over 2. What's 2 times 8? 2 times minus 7 over 2, first term, plus n minus 1 times half is equal to 675. Now we're going to take 675. Let's see if we should do that. Okay, let's keep it like this. That's n over. Let's cancel out the fraction. Take 675 multiplied by 2. So get rid of that mod 1. 675 times 2. I've got 1350. So 2 times the 2 and the 2 cancels out inside here. So in the bracket I've got minus 7 plus half n minus half. So I've got n into half n, minus half minus 7 is minus 15 over 2. You can check this up. Minus 7 minus half, that's minus 7.5. That's 1350. Alright, so we're going to open this up. We're going to get half n squared minus 15 over 2n minus 1350 is equal to 0. We're going to multiply this entire equation by 2 again. So we got n squared minus 15n minus, what's 1350 times 2? I've got 2700. Now we're going to use a calculator here. Very large numbers, right? So we're going to use n, and n is equal to 0. So we write n equals, or n equals, use a calculator and solve. Let's see, mod 53, or you, obviously if you don't have this calculator you need to use the quadratic formula to solve this problem. A is 1, B is minus 15, and C is minus 2700. So we got answer which is 60, and the next answer we got is minus 45. So n minus 60, n plus 45. So we can clearly see that this can't be the answer. We're going to write reject. Why reject? Since n has to be an element of natural numbers. What's natural numbers? 1, 2, 3, 4. So because it needs to be positive integers, basically. You can write positive integers or natural numbers. You don't get term 0, term minus 1. You get term 1, term 2, term 3 in arithmetic sequence. So 1, 2, 3 are natural numbers. That's the reason why we reject minus 45. It's not part of the natural number set or positive integer set. So we only have one answer, n equals 60. So we can write therefore S60, the sum of the first 60 terms, is equal to 675. There's it here. Calculate the value of n. The cell must calculate the value of n. There's it here. Alright, so we can take that out. N equals 60. Next problem. The questions at the end is always a little bit challenging. It's like level 4 types questions where you need to apply critical thinking. A new sequence is formed by squaring each term of the given arithmetic sequence. Determine which term of the new sequence will have the smallest value. So nice question here. The new sequence is formed by squaring each term of this. But now read the question further. So I'm going to continue the sequence and say, okay, this is not the new sequence, that's the old sequence. The new sequence is just squaring. So what is Tn inside here? Let's put Tn here as well. That was half n. Tn was half n minus 4. That was my Tn formula, right? Now if I square the new sequence, so the new sequence will now be minus 7 over 2 squared minus 3 squared minus 5 over 2 squared, right, dot dot dot, and this will become half n minus 4 squared. There, I just answered your problem. So the new sequence Tn formula will become a quadratic. Tn will now become now simplify this, half n minus 4. So if you simplify this, you're going to get quarter n squared. Half times minus 4 is minus 2 times 2 is minus 4n. I'm squaring this binomial, plus 16. So determine which term of the new sequence, will have the smallest value. The smallest value, how do we solve that? It means the minimum value. Minimum value is from this function. We know that this is a happy phase function. So we're going to try to work out x value of the turning point, which is minus b over 2a. If you do minus b over 2a, you're going to get minus 4 over 2 times quarter, right? So I've got 4 divided by half, which is 8. Now you take the value of 8 and you substitute it into remember we're saying xtp, not really xtp, it's like n. Your variable is n, so you're going to say n turning point is at 8. So you're going to substitute 8. The 8th value will be the minimum. Determine which term of the new sequence will have the smallest value. Which term? So term 8 will have the smallest value. So term 8 is equal to quarter into 8 squared minus 4 times quarter, 4 times 8 plus 16. We can even find the minimum value here. So you're going to have mode 1. So you say quarter into 8 squared minus 4 times 8 plus 16. So the minimum value is 0. So but they asked which term. So term 8 will have the smallest value. I hope you understand, guys. Alternatively, what you can do is you can differentiate this. So you'll get 2n minus 4 is equal to 0. Half n minus 4 equals 0. Then you will get n is equal to 4 divided by half, which is 8. So you can also use that method to solve. That's it. Nice question. So these are some of the new questions that we see. That one, even the other question here, this is something new, right? Some level 4 questions. What else? Yeah, this was also something nice, and this was kind of tricky, right? I don't know why they gave this problem here. No idea. 1.1.3. Okay. Right, continuing with our problem now. We were on question 3.1.3. Right, that's done. Let's move on to geometric sequences now. 3.2. Now remember convergence and divergence. When does the series converge? And they said it's an infinite geometric series. So when will the series converge? It converges if you have -1 less than r less than 1. So what's r equals? R is term 2 divided by term 1. Term 2 divided by term 1. If you take term 2 and divide it by term 1, you have 2 into x plus 1 all squared divided by x plus 1. So x plus 1 cancels out. You got 2x plus 2. That's what we have. So we're gonna put this 2x plus 2 inside here. 2x plus 2 less than 1. Bring the 2 over, so we get -3 less than 2x. And take the 2 over, you're getting -1. 1 minus 2. Because when you take it over, we need to subtract. Take it over, we need to subtract. So 1 minus 2 is -1. Divide everything by 2, we get the answer -3 over 2. X is greater than -3 over 2, but less than -half. So that's my answer. Alright, for which values of x will the series converge? This one here. Now you can clearly see that they're saying that if x equals -3/4, determine the numerical value of the first term. Right, so quite simple because it's just direct substitution. Right, what's the first term? First term is x plus 1, term 1. Term 1 is equal to x plus 1, and the value of x is -3/4 plus 1. 1 minus 3/4 is just quarter. You can use a calculator to verify. Right, so we have the answer there. Next one, write the series in sigma notation. Right, so we need to write the series in sigma notation. Now the problem is problem with this question, because writing the series in sigma notation, the original series in sigma notation, or is the value of x equals -3/4, and then we write in sigma notation. Write the series in sigma notation. The first 3 terms of an infinite geometric series are given. Write the series in sigma notation. Okay, if x is equal to -3/4, then we'll write the series in sigma notation. Alright, if x equals 3/4. If x is equal to 3/4, then remember what's r. R is 2x plus 2. 2x plus 2. How do we get 2x plus 2? We took that one, cancel out with this one, and we distributed the 2 inside. Yes, so 2x plus 2 is r. 2x plus 2 is r. Then x value is 3/4, so 2 into 3/4 plus 2. So we have 3 over 2 plus 2. 3 over 2 plus 2 is, don't say plus 2, say plus 4 over 2, so it's 7 over 2. 1.5 plus 2, that's 3.5, which is 7 over 2. So the value of r is 7 over 2. We know the Tn formula is a r to the power n minus 1. Okay, so the value of a was quarter. R is 7 over 2 to the power n minus 1, Tn. And now we can write the series in sigma notation. So we can say the series in sigma notation, what's the series? The series is x plus 1, the first value is quarter, so we can say quarter plus, what's the second value? First value is quarter, the second value is 2 times x plus 1 all squared, so that's that's quarter. Quarter squared is 16. 1 over 16 times 2. 1 over 16 times 2 is 1 over 8 plus the third term is 4 times 1 over 64, should give me 1 over 16 plus dot dot dot, and that's basically equal to sigma first term is quarter, the second term is, what's a common ratio? Why did we get 7 over 2 as a common ratio here? Common ratio is 1 over 8 divided by 1 over 4. Common ratio was 2x plus 2. Oh, the value of x is negative 3/4. Okay, that's where we went off. So negative 3/4. So negative, yes, so we got half, that's right. So minus 3 over 2 plus 2, that's half. We got a common ratio of half as well. Right, so that shouldn't be 7 over 2, that should be half. Right, and now remember, we can simplify this. We can simplify this as, you can leave the answer like this or simplify. Quarter can be written as 2 to the power minus 2. This here can be written as 2 to the power negative 1 to the power n minus 1. Simplifying this, 2 to the power negative 2, and then adding this up because we have same bases. We can say negative n plus 1. So what you have is 2 to the power negative n minus 1. So you can say that, or just write this as is. Alright, 1 over 8 divided by quarter 4. Yeah, that's right. So we got n equals 1 to infinity, because that's an infinite series of Tn formula. Tn formula of the Tn formula. So n equals 1 to infinity. What's the Tn formula? Tn formula is quarter into half to the power n minus 1. And if you simplified it like this, you can also write it as n equals 1 to infinity 2 to the power negative n negative 1. Right, so I hope you're understanding, guys. Next problem, calculate the sum to infinity of the series. Right, so now if you want to calculate the sum to infinity, is a over 1 minus r, don't forget the formula, right? Sum to infinity is a over 1 minus r. What's the value of a? Quarter. 1 minus r, what was r? Half. So you got quarter divided by half means times 2. So the sum to infinity is just half. So, or you can just type the entire thing out on the calculator. You got put the fraction button first, fraction, mode 1, fraction, not the fraction, because quarter divided by 1 minus half is half. Right, so quarter divided by half, half. Right, so I hope you understand, guys. So that's what they want here. Next question. Question 4 is on hyperbola, as we see here. On functions. So purely grade 11 problem. Right, so it is given that the asymptotes of f of x intersects at 4 and 3. So if the asymptotes intersects at 4 and 3, then what we have here is, remember, 4 and 3 is somewhere here. So we have a horizontal asymptote at the value of y equals 3, and we have a vertical asymptote at the x value of 4. Right, so we can clearly see the value of, so we can say f of x is equal to 6 over x minus 4, because to get an asymptote the denominator must be 0. So 4 minus 4, so you can clearly see x is equal to 4. Right, and q is just the horizontal asymptote, so plus 3. That's quite simple. Next problem, we'll solve for 4.2. Determine the intercepts of f with the axis. So we're looking for the x-intercepts and the y-intercepts. Right, so y-intercept is just making x is 0. That's quite simple. right? So if you make x 0, you're finding the y-intercept. So how do we find the y-intercept? You're going to say f0, so you're getting 6 over 0 minus 4 plus 3. What is 6 over minus 4? That's 3 over minus 2, so negative 1.5 plus 3, so you should get 1.5, which is 3 over 2. You can just check it up on the calculator mode 1. Alright, so you got 6 over minus 4 plus 3, so you get 3 over 2. So what's the intercepts with the axis? This implies you're writing it in coordinate form, 0 and 3 over 2. That's my y-intercept. Right, now to find the x-intercept, you need to make this function equal to 0, so you need to say 6 over x minus 4 plus 3 is equal to 0. We're going to take the 3 over and cross multiply, so negative 3, 6, right, put it over 1 and now cross multiply. We're getting negative 3 into x minus 4, and 1 times 6 is 6. Open it up, minus 3x plus 12 is equal to 6. Take that over. 6 minus 12 is negative 6. Therefore, x is equal to negative 6 divided by negative 3, which is 2. So what's the coordinate of the x-intercepts? 2, 0. Sketch the graph of f, clearly showing the intercepts with the axis and any asymptotes. Right, so we're going to sketch this graph. Right, so first we know our horizontal and vertical asymptote, right? My horizontal and vertical asymptote was, we just need a rough sketch. Right, so I'm going to draw a solid line, I'm going to break it up, right? So that's 4, right? And that was 3 here. Right, so remember this is my axis, x-axis, y-axis. That's my x-axis, that's my y-axis, that is 0. I need to break up the asymptote, right? Let's just extend this line here. Right, so we're going to break up this line here because that is an asymptote. Right, so make sure you draw it as broken lines. Remember the equations where x equals 4 and y equals 3. Then the next thing is, we know the graph is in the first quadrant and the third quadrant, so the asymptote makes a quadrant. So there's quadrant 1, quadrant 2, quadrant 3 and quadrant 4. So we can clearly see over here there's nothing intersecting, so that's one graph gone. And then my x-intercept was what was my x-intercept? 2, 0, so exactly in between here, that's 2, 0. And my y-intercept was 1.5. 1.5 will be right here because that's 3. Y-intercept was 1.5, right? Or 3 over 2. And now we're going to draw the second graph here. I'll just try to make it a curve, right? Again, right, it's a hyperbola curve. Right, that's going a bit off. Right, let's see. And this part over here, let me just, not a straight line, I should curve it up here. Again. Alright, so that's let me try, that 2 is causing a problem. Right, that should do. Right, so that's my graph of f. I can label it as f graph, and that's it. 4 and 3, and that's the graph of f. We showed the intercepts with the axes and the asymptotes, right? So there's a y-intercept, there's the x-intercepts, these are the asymptotes, x-y axis, all done. The graph is in the first and third quadrant. Perfect. Moving on to the next question. G. G is the one of the axis of symmetry of f and is the decreasing function. Determine the equation of G. Now you get two types of axis of symmetry, right, in a hyperbola. So x minus 4 plus 3, that was the equation. The axis of symmetry is you go into this pattern, right, and you cut it here. You put a negative in the front in the denominator, you get a negative axis of symmetry, right? And if you put a, you take it as is, so there are two axes of symmetry. We want the positive one, decreasing function. So we're going to say g of x is equal to negative into x minus 4 plus 3. So what we have, negative x plus 4 plus 3. So we have negative x plus 7. Right, so that's the decreasing function because gradient is negative. In other words, we want the negative. If you wanted the positive, you just add up x minus 4 plus 3. So that's my answer for g of x. I hope you understand, guys. And the last question. Minus 3 and 2 is a point on f. Determine the coordinates of the image of this point after the reflection in G. So you're reflecting around this line. Alright, so you got minus 3 and 2, and line of reflection is y equals reflect on. Right, so reflected on y equals minus x plus 7. Right, so now remember, we can get the y transform point. So what's the determine the coordinates of the image of this point after its reflection. So the transform point, what's the y transform point? Minus x plus 7. So there's your x, y. So you're going to say negative x plus 7. Remember, negative x plus 7. What is x? Minus 3 plus 7. So what we have? We have 4 plus 7, which is 11. That's a transform point. Now, to get the x transform point, you need to solve this transformation equation. So we're going to say y equals negative x plus 7. So this is your x transform point. So this implies I'm going to take that x over and bring the y over. So x transform point is equal to negative y plus 7. And what's y? The value of y is 2. So negative 2 plus 7, which is equal to 5. So what's the point here? Determine the coordinates of the image of this point after the reflection in G. So you can say minus 3, 2, which is a point P, now becomes point P1, which is 5 and 11. So 5 and 11. Let's check if we can work this out. It's a difficult question. All right, let's see if we can work this out in a different way using graphs. Right, so if we use this graph here, let's check if we can use graphs to solve O. Right, so I'm going to copy this graph and see if we can solve this O. Method 2. Let's check method 2. The second method is, let's draw the graph of G on the same system of axes. The graph of G is 7, the y-intercept is 7, and the x-intercept will also be 7 because it's a decreasing function, right? So 7 and 7. I think I probably need to go and extend this. This was 3, 7 will be somewhere around there, right? This is 4, 6, I'll take 7 there. So, and it needs to go through this point as well. The main thing is an axis of symmetry. Right, so that's the graph of g of x. Now let's check what's happening here now. If you're looking at minus 3, 2 is a point on f. Minus 3, 2 is a point on f. So where's minus 3 and 2? That's minus 2. So minus 3 and 2 is here. Alright? That's a point P. We located the point P. Now we're reflecting this point P directly across this line. That's a problem, and we're reflecting this point across this line. It needs to be reflected across this line. That's the problem. We need to reflect this point P across this line. So is there a way to solve this? Using geometry. Minus 3, 2. That point there is important. If we can get this point, we know that the distances are the same. The distance from here to there will be equivalent to the distance from here to there. We know that the distance must be the same. We can clearly see that point 5, 11, what we had above is correct. 5 and 11, that's a point P, the image, the transform point. If we can get this here, if we say that this is kind of like perpendicular, if you say that this is perpendicular, then maybe that can help us. And we know that this is also the midpoint, not knowing this. If we don't know this, then this is a midpoint. Yeah, I'm sure there's a geometrical way of solving it, but can't really figure this out now. Yeah, I should. Let's check. This is perfect. This is how we do it, because that's a line of transformation. Minus 3, 2. What's the geometrical method of working this out? Okay, if you figure it out, let me know in the comments. Right, there should be a geometrical method, obviously, of figuring this out, because we can't, but it's going to just take me long to solve this, because from here to there I need to look at that one, and I need to look at this triangle here as well. Yes, if I can get the vertical distance here and there, then I can take a vertical distance and a horizontal, and I can probably use translation to solve this. But anyways, let us move on, because we already have the answer, which is 5 and 11, which is correct. I was just looking at the location of the point, not really going to prove this. Right, moving on to the next question. We have question 5. Right, so what we are given here is a graph which is in TP form, right? F of x, x minus p all squared plus q. So that's the form, and we're given an exponential function, not a hyperbola, it's an exponential graph, g of x. So we have f of x, g of x. We can clearly see that the graph of g cuts f at points a and b. So it's cutting at that small point there. So those are basically the points of intersection. B is the turning point of f. So the graph of g goes through the point B. So write down the coordinates of B. Simple. What's the coordinates of B? Take opposite sign here and minus 9. So 1 and minus 9. That comes straight from the TP form. 1 and minus 9. That's the coordinates of B. Problem solved. Next one. The values of x for which both the graphs are decreasing. When is it decreasing? The graphs are decreasing here. We can see the exponential function is decreasing everywhere, and this is decreasing until that point, and that x value is 1. Right, so that x value is 1. So x is less than 1. For x less than 1, both the graphs are decreasing simultaneously. For which values of x are both graphs decreasing? They wanted both graphs, right? So x less than 1. F of x is decreasing and g of x is decreasing. Determine the coordinates of the x-intercepts of f. To find the x-intercepts of f, we got f of x, which is x minus 1 all squared minus 9. So y equals, to find x-intercepts, right? X minus 1 all squared minus 9 is equal to 0. Now don't go and open up this whole thing. Just solve it like this. Simpler. Because it's in TP form. Take the 9 over and then square root both sides. So when you square root both sides, it becomes plus minus 3 because we're square rooting. So x minus 1 is equal to negative 3, or x minus 1 is equal to positive 3. So x is equal to negative 2 because we need to add 1, and or x is equal to 4. Okay. If you try to solve it the other way by opening this entire thing up, or you can do that. That's x squared minus 2x plus 1 minus 9 is equal to 0. Right? So you got x squared minus 2x minus 8 is equal to 0. You can factor it out into two brackets. So you got x minus 4 and x plus 2. So x is equal to 4, or x is equal to negative 2. So we get the same answer. Right, so determine the coordinates of the x. They want the coordinates, right? So write it in coordinates: minus 2, 0, or 4, 0 in coordinate form. Next question. Show that a is equal to 9. Nothing difficult there. Remember, g of x goes through the point B, right? G of x goes through the point B. What's g of x? Negative a to the power x. So we know g of x is y equals, we know g is y equals negative a to the power x. That's a g function. At point B, which is 1 and negative 9. 1 and it passes through the point B, which is 1 and negative 9. So you're going to put negative 9 for y, and x value 1, negative a to the power 1. Problem solved. So a is equal to 9. Therefore, you have to show the substitution for this. You must show the substitution for x and y. So there I showed it here. Next one. Determine G inverse in the form y equals. Let's find G inverse. So we know that G is a function. We know that G is the function y equals negative. What's the value of a? Negative a to the power x. So y equals negative 9 to the power x. Now remember, the negative is on the outside, so I would recommend putting brackets here so you don't mix it up. Negative 9 to the power x. Right, perfect. Now we need to find the G inverse. Right, so G inverse is x equals negative 9 to the power y. We're going to multiply both sides by negative, so you get negative x equals 9 to the power y. Now we solve for y. So y now becomes log negative x base 9. That's my answer. So log of this answer, base 9. Remember, the base, exponential base, and the log base remains the same. So log negative x base 9. That's y equals. So what we needed to write in the form y equals. So that's my answer. Now remember, the restriction for x is it has to be positive. So x over here needs to be negative, x needs to be positive. So x has to be less than 0. That's my restriction for x. Sketch the graph of G inverse, right? Sketching the graph of G inverse is a reflection of this graph, right? It's a reflection of this graph, right? Around the about the line y equals x. Right, so let's take some coordinates from this graph. We know the coordinate is 1 and negative 9 becomes 9, and it becomes, remember, we had 1 and negative 9 as a point, so that one will now become negative 9 and 1. It's a reflection about the line y equals x. That's what an inverse function is. So this was for G, and that's G inverse. If you choose another point on G, like look at the y-intercept, it should go through negative 9 to the power 0. So negative 1, 0 and negative 1. We know that's on G. And so on G inverse, it will become negative 1 and 0. Let's look at these points. Solve. So we know negative 9 and 1 is somewhere around here, right? Negative 9 and 1. Negative 9 and 1 should be there, right? And then we got negative 1, 0. Negative 1, 0 is there, right? So that's the x-axis, that's the y-axis, that's negative 1, 0. And remember, this here has an asymptote of x equals 0, so the log graph will have an asymptote of the asymptote of the exponential function is y equals 0, horizontal asymptote, so the log graph will have a vertical asymptote, so broken line here. And now we sketch this graph. Right, so it's a log graph going like this. Right, obviously it's not going like this, it should go negative 9 and 1, should go higher up like this, it's like extending outwards, but it's still going, is kind of like diverge. Let's see, it has to go up and there, gradually increasing. So you can say that point is negative 9 and 1, and this is 1, 0. That should be enough to sketch this graph of G. That's G inverse graph. Okay, intercepts with the axes, we can see the intercept here is, if you're making x as negative 1, so log of 1 base 9 is 0, log of negative 1 base 9, putting negative 1 there, so negative 1 and 0 is the x-intercept. You can say x-intercept is negative 1 and 0. Perfect. Right, so that's my log graph. Next question, 5.7. Nice question here. They always ask these types of questions at the end, right, on log graphs. G inverse x must be greater than equal to 2. So now what does that mean? It means that for which values of x is G inverse x greater than equal to 2. So what we actually do here is we have a log graph, right? What they're basically asking us for is something like this. I'm just copying the log graph from above, right, but in a more general form. Right, so that's a log graph I have. Now we want to know this point here. So we know this y value is equal to 2, right? The y value of 2 on the G inverse graph is the x value of 2 on the G graph. So if I substitute x value 2 on the G graph, x value 2 on the G graph, what's a G graph? Let's see. G of x was negative 9 to the power x. So now y equals 2, I'll substitute it into x equals 2 here. So that's negative 9 squared. So I'm getting negative 81. The y value as negative 81. So which means that this value here will be negative 81 as the x value, because remember these are the values on G. So 2 and negative 81 occurs on G, so we need it on G inverse. That's the point on G. The point on G inverse would be negative 81 and 2. We can clearly see the y value is 2. Now we want greater than 2. So is all those points for which values of x, right? So we want all these answers. So what's the answer? X is less than negative 81. Now let's check if this answer works. So just to check the answer, I want to check the answer. We remember y equals log base 9 negative x. So I'm going to substitute negative 81 and see if I get 2. So I've got log base 9 negative 81, right? What we get? We get 2. But now if I put negative 82, do I get an answer which is, yes, more than 2? That's what we want. G inverse must be more than 2. So there, we got the answer. So nice question. So this is like another level 3, 4 type question, thinking questions. Yeah guys, you must expect those types of questions to come up at the end. Let's look at question number 6. More functions. So much of functions in this paper. Alright, so as we see this function here, we got question 6. Let's see what we want here in this. So in this problem, what we have the graph of h of x, parabola in the standard form ax squared plus bx plus c. We have the straight line which is going through the point minus 4, 6, and it's also going through the parabola. But on the parabola what we see is we have two x-intercepts and we have a point. So perfect, we can find the equation of the parabola. Yes, after we find the equation of the parabola, straight line may be drawn. Minus 4 and 6 are the coordinates of one of the points on the intersection between h and s. Okay. Show that a equals minus half, b equals minus 2, c equals 6. Yes, we can show that. 6.1. Alright, 6.1, we can find this equation of h, alright, because we can start off with the equation a into x minus x1 into x minus x2. What's the 2 points? Minus 6. So a into x plus 6, putting into factors, and x minus 2 at minus 4 and 6. Now the purpose of substituting another point is to find the value of a. So we got 6 equals a into minus 4 plus 6 is 2, and minus 4 minus 2 is minus 6. So we got 6 equals negative 12a. This implies a equals negative half. After you get the value of negative half, take this value and put it back into this. So what we have, therefore y equals negative half, and open this part here up, x squared, alright, plus 6 minus 2 is plus 4x, and 6 times minus 2 is minus 12. And then open it up, we got minus half x squared minus 2x plus 6. So the value of a is minus half, b is equal to minus 2, and c is equal to 6, as we see here. So we got the entire equation of the parabola. Next question. Determine the maximum value of h of x. Yes, to find the maximum value, we can find the derivative or just use minus b over 2a. So x value of the turning point is minus b over 2a. B is minus 2, so, and 2 times a is minus half. We can clearly see we have 3 negatives, so negative 2 divided by 1, so 2, negative 2. X value of the turning point is negative 2. You substitute negative 2 into the original equation, which is, you find h of negative 2. A is minus half. Minus half x squared minus 2x. What was h of x? Let's write the h of x formula. Minus 2x plus 6. So h of negative 2. Remember, to find the y value of the turning point, you can just use minus delta over 4a. You can just use, you can go straight into y value of turning, minus negative delta over 4a. You can also use this to get straight to that answer. But anyways, I like to work it out like this in steps. So we got minus half into minus 2 squared minus 2 times minus 2 plus 6. Okay, so if we add up everything, this is 4 times minus half, that's minus 2. 4 times half, which is minus 2, plus 4 plus 6. So we have 8. Therefore, max value is 8. Therefore, max value is equal to 8. I hope you guys understand. Max value is 8. So now we have the maximum here, which is negative 2 and 8. Perfect. Now let me show you a trick. Actually, the calculator gives us the minimum and the maximum value. So go to mode 5 3. Enter these values. We got minus half, minus 2 and 6. See, maximum, x value maximum minus 2, check, and y value maximum 8. So the calculator actually gives us the maximum value. Y value of maximum is, y maximum value is 8. There. So it occurs at minus 2 and the maximum value is 8. Amazing. Just by entering A, B, C into the calculator, I can get the min-max value. Next question. Determine the equation of S if the gradient is equal to negative half. Simple. Alright, so remember the gradient is negative half. So what's the equation of S? The equation of S is y minus y1 equals m into x minus x1, and we got y1 x1 y1 as a point that goes through minus 4 and 6. So it's at minus 4 and 6. At minus 4 6. So y minus 6 equals, gradient is minus half, x minus minus 4, x plus 4. So we got minus half x, minus 2, and taking the 6 over, plus 6. So S of x is the same thing as saying y equals minus half x minus 2 plus 6 plus 4. And we can clearly see that the y-intercept is positive in the graph. So that point is 4. Right? That point there should have been 6. Yeah, as we find the points, we're going to put it into the graph. Last one. For which values of k will s of x plus k have two real roots that are opposite in signs? Alright, so 6.4. So see what they're saying. S of x plus k equals h of x. Now what is s of x plus k? Have two real roots that are opposite in sign. Right, let's take the value of k over. Right, so we are looking at s of x. What was s of x? Minus half x plus 4. Difficult question, right? Plus k is equal to, what's h of x? H of x is minus half x squared. Let's copy this. Right. Now I'm going to write this entire thing out, take it over to the other side besides the k. Don't take the k over, keep the k there. Right? And say that's minus half x squared minus 2x plus half x. That's minus 3 over 2x. Right? And plus 4, we can take this over, you get plus 2. So basically I did h of x, h of x minus s of x. So h of x minus s of x is equal to k. That's what I did. Now what I'm going to do is I'm going to two real roots that are opposite in signs. It needs to be opposite in signs. Minus half x squared minus 3 over 2x plus 2. Right, what I'm going to do is solving my method, because I've got a new function f of x is equal to k. I'm going to draw this graph. So y-intercept is 2 and it's a sad face, minus b over 2a. So I want the turning point here. Alright, so I'm just going to put it into the calculator. 5 3 minus half, right, minus half minus 2 minus 3 over 2 minus 3 over 2 and 2. My x-intercept is 1 and minus 4. So what's x-intercept for this? Minus half x squared minus 3 over 2x plus 2 is equal to 0. So I'm going to multiply everything by negative 2. So I've got x squared plus 3x minus 4 is equal to 0. If I solve this, x minus 4 and x plus 1. So that's why I'm getting x is equal to negative 1, or x is equal to, should be plus 4 and then the other way around, because it's plus 3 here, so it should be plus 4 and negative 1. Right, plus 4 and negative 1, so x is equal to negative 4 or x is equal to 1. So that's what I'm checking here, 4 and again 1 and negative 4. And see what's my x value maximum at minus 3 over 2 and 25 over 8. But I just need this, I need the, let's draw this graph. Obviously method is important in solving these equations. Let me solve this method and then try to figure out if you can use the original graph to, you know, solve. Alright, so I'm trying to draw this graph. We know it's a sad phase graph, right? Minus 4 and 1. Minus 4 and 1. And my turning point is here at minus 3 over 2. Turning point is somewhere around here. Right, so my turning point is somewhere around here. So which is, and my turning point is there, right? So minus 3 over 2, and the y value here is basically 25 over 8. Right, now we want to know when it will have opposite sign. So what's the y-intercept here? 2. So what you needed to focus on is there was no need to do all this. All you need is the y-intercept here, right? And we need the turning point value. So if I cut below, see, if I horizontally cut below 2, if I cut between here, if I cut in between, you see, if I cut in between the turning point and the y-intercept, so we don't even need the turning point, we don't even need the x-intercepts, right? So, but how do we know whether the way is turning? Could have turned here below, no, it couldn't have turned below 2 because that's the y-intercept. It has to turn above 2, right? We want roots that are of opposite sign. At the moment the roots are opposite sign, so any value less than 2. So what's the answer? K is less than 2. So therefore the answer is K is less than 2. Why are we saying K is less than 2? Because for less than 2 you're going to get one root which is positive, one root negative, positive, negative, positive, negative. You'll always get positive. So for which values of K will have 2 real roots that are opposite in signs? It has to be opposite in signs. So the values of K which is less than 2. Yeah, so it all depends on this. Values of K which is less than 2. Yeah, you have to picture the graph. So I would suggest doing this method here. We don't really need the y value of the turning point, so that's not important. Just put the x-intercepts and the y-intercept and then solve. Obviously you can locate the x value of the turning point by taking the midpoint of 1 and minus 4. Yeah, so there's another difficult problem here, more like level 4. Right, and then last one. Describe the translation that H will undergo to become, describe the translation. So how are we shifting the graph so it becomes like this? So what was h of x function? My h of x function was minus half x squared minus 2x. Was it minus 2x? Minus half x squared minus 2x. Minus half x squared minus 2x plus 6. That was my h of x function, right? So we want to know how is it transformed to this point. Well, what is p of x? P of x is minus half. Now let's open this function up. We got x squared plus 4x plus 4. Opening this function up, so we got minus half x squared minus 2x minus half times, that's minus 2, right? So how you go from h plus 6 to minus 2? So you have to shift this entire graph 8 units down. So you need to subtract 8. So what you're going to do is we're going to say translate the graph of h 8 units down to obtain p of x. Okay, so 8 units down, that's my answer. Okay, that's what you should be writing, 8 units down, because from plus 6 how you go to minus 2? We need to move the graph 8 units down. Another difficult question, not difficult, a simple question that was. Let's look at 7.1. So now we are officially on calculus, right? We're done with functions and stuff. We're almost towards the end, right? Just hold on. Right, so what we have, f of x, which is 2x squared plus 4, right? Determine f from first principle. So what we have is f prime x. We're going to find derivative of f is limit as h approaches 0 of f of x plus h minus f of x all over h. Instead of writing all over h, I usually write it as, I'm going to take out the 1 over h out, okay, and then I'm going to write it like this. What's f of x plus h? That's x plus h substituted into x, so 2 into x plus h all squared plus 4 minus f of x, which is 2x squared plus 4. Now simplify. Limit as h approaches 0 of 1 over h. Remember I took out the 1 over h. So we left with 2. Open this up. That's x squared plus 2xh plus h squared plus 4 minus 2x squared minus 4. So you can see plus 4 and minus 4 already cancels out. Limit as h approaches 0 of 1 over h into 2x squared plus 4xh plus 2h squared minus 2x squared. Now we can see the 2x squared and the 2x squared cancels out. So in all polynomial functions, remember, all of this will cancel out when you're doing first principles, in polynomial functions only. Limit as h approaches 0 of 1 over h. We can take out h as a common factor, and we're left with 4x plus 2h. Now what happens? The h and the h cancels out, and now we are left with limit as h approaches 0 of 4x plus 2h, which is basically equal to 4x. I hope you understand, guys. Right, so what's f prime x? 4x. And you know from rules, 2 times 2 is 4. Subtract 1 from the power. Derivative of constant is 0. So we get 4x. Next question. A tangent to the graph of f has a gradient of minus 12. Determine the equation of the tangent. A tangent to the graph of f. Right, so we have a graph of f which is basically, if you think about the function, it's a parabola function. Just to explain, 2x squared plus 4, right? So it's a graph that's like this. Trying to understand this problem, alright? 2x squared plus 4 is a graph like this, shifted 4 units up, 2x squared graph. Right, and the tangent has a gradient of negative 12. So obviously gradient negative 12, the tangent will be on this side. Okay. So we need a point of contact. How do we get the point of contact? To get the point of contact, remember, that's the point of contact here, the x value and the y value, or the a and the b value, and the gradient is negative 12. Now how do we get a gradient of negative 12? We say f prime x is equal to negative 12. So that's what you need to do. We need to say f prime x is equal to negative 12. So what is f prime x? 4x is equal to negative 12. This implies x is equal to negative 3, as we said. Right. So what's the answer? X is equal to negative 3. So what's the y value? You need to take negative 3 and substitute it into 2x squared plus 4. So y value is 2 into negative 3 squared plus 4. That's 3 squared is negative 3 squared is 9. 9 times 2 is 18 plus 4 is 22. So what's the point of contact? Negative 3 and 22. So what we have at point of contact, negative 3 and 22, we have y minus y1 equals m into x minus x1. Determine the equation of the tangent. We want to find that. So y minus y1, what's y1? 22, and m is negative 12 into x minus, what's x1? Minus 3. So minus 3 becomes plus 3. So we got negative 12x, take that over, negative 36, and take that over, plus 22. So we need to open this up and then take the minus 22 over. So what's the equation of the tangent? Negative 12x minus 14. Well, this line here should be a little bit more slanted. Obviously the diagram is not drawn to scale. A little bit more like this. It's a very steep yeah, so it's something like that. Minus 12 minus 14. Alright, so this is the equation of the tangent line. I hope you guys understand. Yeah, this is also basically my first time doing the paper. Right, so let's see, 7.2.1. Now we want to find the derivative, right? We're going to find derivatives using rules. Right, so now this denominator gives it away because we need to factorize this. So you're going to say f of x is equal to, obviously you're going to have 2x x minus 4. I'm just using a cheat method because I know that's going to cancel out with the denominator, right? And x minus 4. So I know this one and this one cancel, but anyways, let's factorize. Mode 5 3, we're going to enter 2 minus 5 and minus 12. You can see one answer is 4, so x minus 4, and the other answer is 2x plus 3. So all we need to we have f of x, which is 2x plus 3. So therefore f prime x is finding the derivative of 2x is 1 times 2 is 2, x to power 0, so just 2, and derivative of constant is 0. That's it. So what's the f prime x? 2. Next question. Now very important in using this notation is writing it in exponent form. Right, so and only drop it after you differentiate. So we're going to say dx, write it in power form, so x to power 2 over 5 inside over outside plus x squared minus 9x. Now differentiate because it's all in power form, so you're going to say 2 over 5 x to power, what's 2 over 5 minus 1? Negative 3 over 5 plus 2x minus 9. 2 times 1 is 2, x minus 9. Now you can write it in positive exponent form, 2 over 5 x to power 3 over 5 plus 2x minus 9. So that should be fine because they didn't say must write it in positive exponent form. So you should get a mark here, right? You should get 1, 2, 3, 4 marks. So they didn't say must write it in that form. It's fine, but this is better form to write it in. I'll just put an asterisk here. 7.2.3. Again, writing it in what you call writing this 7.2.3 in standard form. Alright, so we're going to split this up and write it in standard form. So we're going to write y is equal to 1 over 6x minus 6, bring the x over, x to the power negative 1. Right, so now we have dy dx, don't write y prime please, right, dy dx, change in y over change in x, that's 1 over 6, minus 1 times 6 is plus 6, x to the power minus 2, minus 1 minus, and we can write this in positive exponent, that's 1 over 6 plus 6 over x squared, right, and that's the answer. You should get 1 mark there, 1 mark here, 1 mark there, and just put an asterisk here because that's extra steps. They didn't ask us to put it in positive exponent form, they just said must differentiate. Okay, alright, perfect guys, we almost close to the paper, right, so almost ending, so just hold on there, right. So next question, question 8. Right, so we have the full cubic function given. Look at this, it's boring because there's no hardly any analysis to do because we have the full cubic equation given. So what we need to find, calculate the coordinates of a, b, c. To find the coordinates of a, b, c, you're going to make f of x is equal to 0. Let me just copy that. right, and put it here. Let me make this equal to 0 and solve. So I'm going to write this in standard form: x cubed minus 10x squared plus 17x plus 28 is equal to 0. Okay, x cubed minus 10x squared plus 17x plus 28 is equal to 0. What we're going to do is open up one small bracket, one big bracket is equal to 0. Then open up three small brackets, because that's what we need. We can see alright, and then you write down x equals, or x equals, or x equals. Now we're going to use a calculator. So this is how we do: mod 5 and 4. So 1, what's the value for b? Minus 10. Then c value 17. Then d value 28. That's it. And let's write down all the answers. That's negative 1, then 7, and then 4. Now put negative 1 inside here, so it becomes x plus 1, x minus 7, and x minus 4. Now very important, guys, you have to show this step. Don't just do these two steps. You have to show this step here. Is important, right? Because you got to mark for that. So you're going to carry this over, and you're going to open this up. So you're going to get x squared minus 7 minus 4 is minus 11x, and 7 minus 7 times minus 4 is plus 28. And now that works out everything, right? So just use a calculator and solve. Now if you don't have a calculator, we're going to put x and x squared. Alright, so now watch. We're going to put x and x squared, right? So x times x squared is x cubed. Now factors of 28, you're going to say 28 and 1. Now this is how you get the middle term. You take these two terms, multiply it out, right? So you get negative 1. Don't take the terms, you take the positive 1 times 1. What do you get? Positive 1 times 1, which is 1. You take the opposite sign, so negative 1, and you add it to the term in the x squared. So you get negative 11, and that's what you put the middle term as negative 11. And then you can factor that out further. Anyways, we're just going to use a calculator because it's allowed, and that's my answer. So what's the coordinates of A, B, C? A was here, B, C. So C is the last point. So A is minus 1, 0. C is the last point. So C is 7, 0. And B is 4, 0. That's done. Next one, 4 marks again. Calculate the coordinates of D and E. D and E are maximum and minimum points, right? So you're going to find the derivative, set it equal to 0. Right, so in order to find the derivative, let's copy this function here, because I need to find f prime x. Right, so I've got f of x here. I need to say f prime x and set that equal to 0. So f prime x, I've got negative 3x squared plus 20x minus 17 is equal to 0. Put that in standard form. You've got 3x squared minus 20x plus 17 is equal to 0. You know how we got that? 3 times minus 1 is minus 3, take away 1 from the power, x squared. 2 times 10 is 20, take away 1 from the power. 1 times minus 17 is minus 17, take away 1 from the power, it becomes x to the power 0, which is 1, and derivative of constant is 0. And now we're going to factorize this, so we're going to get 3x and x equals 0. Now factors of 70, you can't get anything because it's a prime number, 17 and 1. So negative, negative, you can see negative 17, so x is equal to 17 over 3, or x is equal to 1. You can check this out on the calculator. Mod 5 and quadratic function 3. What do we have? We have not negative 3, standard form. 3 minus 20, and we got 17. See what we have? 17 over 3 and 1. Now if I substitute x value 1 inside here, f of x function, you're going to get y is equal to, substituting 1 in this function here, mod 1, right? Substituting 1 here, we got negative 1 plus 10 minus 17 minus 28. Negative 1 plus 10 minus 17 minus 28. I got negative 36. So where's 1 and negative 36? That's the coordinates of D. Okay. Right, and that's the minimum value, local minimum. Right, and local max, that's 17 over 3. So y is equal to, you're substituting 17 over 3, right? Minus 1 into 17 over 3 cubed to the power 3, plus 10 into 17 over 3 squared, minus 17 into 17 over 3, 400 over 27. Right, so what's the coordinates of what they said? D and E. E is the maximum, yeah. Right, so at E we have a local max. Right, so, or you can just say maximum. So coordinates of D and E. E is 17 over 3 and 400 over 27. You can write it in coordinate form. E is what is 17 over 3? That is 5 comma something. 17 over 3, that is 5 comma 67, 5 comma 67, and 400 over 27, 400 over 27 is 14 comma 81. Right, so you can also write it in coordinate form like that. That's right. So moving on to the next question. Determine for which values of x is the graph of the graph is concave down. Concave down. Find double prime x. All right. Concave down means f double prime x less than 0. Concave down means f double prime x less than 0. So what's f double prime x? Right, so we need f prime x. F prime x, the original f prime x, alright, that's what we need. The original f prime x was this, right? So f double prime x will be minus 6x, minus 6x, 2 times minus 3 plus 20, and we're going to solve less than 0. So what we have, minus 6x is less than negative 20, so x is greater than 20 over 6. Dividing by negative, change the sign, which is x is greater than 10 over 3. Now let's check for x value greater than 10 over 3, is it concave down? Yes, for greater than 10 over 3 is somewhere around here, right? That's 10 over 3. The graph is becoming concave down. And less than 10 over 3, concave up. At 10 over 3, inflection point. Next question. When is f prime x decreasing? When is it decreasing? Not f of x. When is f prime x decreasing? No, they said when is f prime x increasing? F prime x increasing basically means, they didn't say f of x increasing, right? Because f of x increasing basically means f prime x is greater than 0. But now they said f prime x increasing. It means it's going to be f prime x is greater than 0. So we basically want now concave up. Right, so we want concave up. Obviously, if concave down was there, so concave up will be x is less than 10 over 3. x is less than 10 over 3. X is less than 10 over 3, it is concave up. Now, assuming that the question said where is f of x increasing, then you have to look at the increase and the decrease of on the graph. So it's increasing here between points D and E. You can see it's increasing. The graph is going upwards, is increasing. So between these two x values, what were the x values here? I think I remember it was 1, and this point over here was 1 and 17 over 3, right? 1 and 17 over 3. So that will be the answer for this problem if they said f of x. So I'll put this as an additional question. So the answer for this will be between -1 and 17 over 3. -1 and 17 over 3. -1 and 17 over 3. That's when it is increasing. Yeah, I think they made a mistake here, because if they ask for concave down, why would they ask for concave up again? But anyways, my answer is making sense. Let me know in the comments if you understand that, right? F prime x increasing, it means where the rate is increasing. Rate is increasing when it is concave up. Concave up is here. Anyways, let's move on to the next question. Question 9. Alright, in question 9 what we have here is a cubic function f with the following properties, right? The x-intercepts of the graph of f prime. So this is the derivative graph, right? Now the x-intercepts of the graph of f prime are x-intercepts of the graph of f prime, but now remember it's a cubic function. F prime graph has -2 and 4. So we know at -2 and 4 there's turning points. Those are turning point values on the f graph. Right, so I've interpreted the first one. We know the graph is concave up for x is greater than 1. The graph is concave up after 1. So we know there's an inflection point here. So this is concave up. So the graph is doing something like this. Concave up is going upwards, right? From 1. At 1. Concave up at 1. Right, so almost it's making sense now, because is it a cubic function that goes like this? Yeah, we have to check. F of 0 is greater than 0. That's no, the graph of f has only one x-intercept. The graph of f has only one x-intercept. The graph of f has only one x-intercept. So maybe it's a graph like this: x minus 0 all cubed, x minus 3 all cubed, right? It's maybe a graph like that. You can have a graph like this, only one x-intercept, right? Remember, these are not x-intercept, those are turning points, right? F of 0 is greater than 0. So that's y-intercept is positive. This is y-intercept. So I'm looking at a graph. Okay, now let me draw a cubic function and decide which one it is, right? So we know we're going to get two types of cubic function. Is it this one? Yes, it is this one, because we can say this is 1, right? Okay, so now because it has only one x-intercept, I'll put the x-intercept here. Perfect, right? And then I'll put this line somewhere around here. Can I put the line there, the y-axis? No, I'll put the y-axis here. Right, so let me move this a little bit higher up, right? See, the graph has only one x-intercept, and I need to move this somewhere around there. Right, so now I know that this point is -2, this point is 1 inflection point and is concave up after 1 for x greater than 1, and there's another turning point at 4, right? And that's -2 is the turning point. There's a point there, the y-intercept is positive, and there's only one x-intercept. Perfect, right? That's the best I can come up with. If you have any alternatives, let me know in the comments. All right, so that's x and that's y. I hope you guys are understanding. So use the information to draw the sketch graph of f. That's my graph of f. It is necessary to indicate the values of x or y intercepts of the graph, but only the x coordinates of the turning points. Yeah, so I've got everything here all done. I hope you guys understand. Yeah, let's move on to the next question. Question 10. Right, so we're almost towards the end where we're dealing with maximization problems now. Right, so in question 10, the manager of a zoo are planning to build a fence around a crocodile enclosure. The sketch below shows the shape of the enclosure. Right, the length of the straight sections will be x meters each, and the radius of the semicircular end or end section r meters each. Okay, as shown in the sketch, the total area of the enclosure is 400 meters squared. Right, so show that x equals this whole thing over here. Right, so we know the total area is this, right? So let's write down area. Area is equal to, remember this is semicircles plus semicircle, the two semicircles, and remember the distance from here to there is 2r. So area of rectangle, right, area of rectangle plus area of the two semicircles, so area of circle. Now area of circle, so what's the area of the rectangle? X times 2r, and the area is 400, plus what's the area of circle? Pi r squared. Problem solved. We're solving for x, right? So 400 minus pi r squared and then divided by 2r is equal to x. Problem solved. Next one. What do they want now? Show that the length of the fencing required can be expressed as, what's the length of the fencing required? The length is x plus the entire circumference of the circle, right? So because there's nothing on the inside, so the length is, in other words, calculating the perimeter, so it's the circle circumference plus, so x plus the circle circumference, which is 2 pi r. So x plus x is 2x plus 2 pi r. Now we know what is x. X is already 400 minus pi r squared over 2r. So you can say 2 into 400 minus pi r squared over 2r plus 2 pi r. Right, so now we're going to multiply everything out and simplify. We can see the 2 and the 2 cancels out, right? And we left with 400, split this up, we're left with 400 over r minus pi r plus 2 pi r. So what do we have? 400 over r plus pi r. That's it. Now calculate calculate the value of the radius that will ensure that the length of fencing required will be a minimum, so as to minimize the cost of building the fence. Calculate the value of the radius that will ensure, we only want the value of the radius, right? Will be a minimum, so as to minimize the cost of the building fence. So we only want the value of the radius. That's all we want. So we need to differentiate and solve, because we want to minimize the length value that will ensure that the length of the fencing required will be a minimum. So minimum length, so you're going to say L prime x. So let's find L of x first. Don't find the derivative, find L of x. Remember, L of x is written like this, but we can't differentiate things like this. Must be in power form. So 400 over r is 400 r to the power minus 1 plus pi r. So L prime x is negative 400, right, r to the power minus 2 plus pi, derivative of this, and we need to set this here equal to 0. Alright, so now what we have is negative 400 over r squared is equal to negative pi. That's what we have so far. So we're going to cross multiply on both sides and take out the negative, obviously. So if you cross multiply, you're going to get pi r squared is equal to, pi times r squared is equal to 400, right? So we got r squared is equal to 400 over pi. Now if you square root both sides, you're going to get r is equal to, what's the square root of 400? 20 over root pi, which is approximately equal to, what's square root of 400 over pi? Square root 400 over shift and pi. So I'm getting an answer of 11.28. 11.28 what meters? What was the radius in meters, r meters? So 11.28 meters. Right, that's my answer. Let's check square root. Is 20 over root pi the same thing? 20 over square root of shift pi. Yes, 11.28 meters. I hope you understand, guys, and I hope you went through the entire problem here with me, right? And if you have any questions or concerns, please write in the comment section below. And one more thing is that I've done, if you're interested in NBTs, I've done an entire 3-hour video full course of the NBT series, and it's in one file, so you can check that up on my YouTube channel as well. And until next time, good luck, guys, and thank you for watching this video.